Hi everyone. So today's video we're going to focus on the limit definition of a derivative and just kind of reviewing that idea. We had three forms of this limit definition. The first one is just the regular derivative of f in general. So any function, the derivative is the limit as delta x approaches 0. You take that function, you plug in x plus delta x minus f of x, all of that over delta x as delta x approaches 0. The reminder, this is kind of coming from this idea of the difference quotient, where we had like f of b minus f of a over b minus a. We can make that derivative more specific to be a derivative at a point, so then it's f prime of c, some specific x value, where those x's just change to c's, whatever number that is that you're trying to find the derivative at. And then there's the alternative form of the derivative at a point, which looks a little bit more like this difference quotient, where x is now approaching the value c that you're trying to find the derivative at. The concept here, the visual idea, is that we're taking that secant line and getting it closer and closer and closer until that limit approaches 0, or until x approaches c, and now it's a tangent line. And the general derivative here creates that tangent line anywhere we want on the function f that the derivative would be defined. So let's do a couple examples here. The reason it's good to know these, they're going to show up most likely on the AP test in some form. That might be recognizing a limit that's given to you is in the form of the definition of a derivative, or it might be kind of creating a limit to be a definition of a derivative. So in this example 1 here, it says write f prime of 2 as the limit of a difference quotient, then estimate f prime of 2 using the data in the table. So notice right away the table doesn't have x equals 2 in it, but we're told to write the derivative as a limit of a difference quotient here. Okay. The other thing to notice is they don't mention the table until the second part where we're estimating. So this first part here is f prime of 2. I just need to write it as a limit of a difference quotient. And since this is at a specific point, I either need to use the derivative at a point or the alternative form of that. And so if we're going to use, let's say, the alternative form, we'd have limit as x approaches 2 of f of x minus f of 2 over x minus 2. We could use the derivative at a point, so this would be an acceptable answer as well. Limit as delta x approaches 0 of f of 2 plus delta x minus f of 2 minus f of 2 over delta x. So either of those would be great for the first part. And then the second part says we want to estimate f prime of 2 using the data in the table. Well, like we said, we aren't given x equals 2, but we're given 1 and 3 and 5. Well, if I want to estimate f prime of 2, I should make a good choice numerically for that. And based on the choices here, 1, 3, and 5, it would make sense to use 1 and 3 as a way to estimate the derivative at x equals 2. So we're kind of finding that average rate of change from 1 to 3. So we could say that f prime of 2 is approximately equal to, and then I would need the f of 3 minus f of 1 over 3 minus 1, which is going to be 19 minus 10 over 3 minus 1 is 2, or 9/4, or 9/2, or 4.5. Then here we have example 2, where it says evaluate each limit. And these are ones where you really got to be able to recognize that definition of derivative, because It's going to save you a lot of work, time, and headache. So it's pretty, like, a couple key things you're looking for. You're looking for that delta x approaching 0. You're looking for the difference quotient idea where you got subtraction on top over delta x. You recognize it here. This is really just saying it's equal to f prime of x, where f of x is equal to, and if you go back up to our definition of derivative, right there, that is your f of x. It's subtracted in the difference quotient, sine of x. And so if I'm trying to find what this limit equals, I know it's the derivative of that function sine of x. So the derivative of sine of x is cosine of x. And there's your answer. This limit, because it's the definition of derivative, just means what's the derivative of sine? It equals cosine. In B, this time we got a lot more numbers in there, but it's still, you've got that delta x approaching 0, and you've got this difference quotient sort of format. And so here you're trying to recognize, well, what is the function? So if this is going to equal f prime of c, well, can you figure out what c is? It's that number that keeps showing up. It's 2. So we're doing f prime of 2, where f of x equals, and then I have to figure out what does the function equal. Well, I can see that I basically got, for derivative at a point, the function should have c plus delta x, or 2 plus delta x plugged in. So that is representing x. So essentially, we've got this piece here is telling me that my function is really x squared minus 3x. And it follows suit here. We also have x squared minus 3x there. And so I now know f of x is x squared minus 3x. Well, we know how to take that derivative. So I could find that f prime of x given that f of x is x squared minus 3x would be 2x minus 3. And then I can plug in f prime of 2 to get 2 times 2 minus 3, which is 1. And last problem real quick here, we've got our alternate form here. So we're looking at limit as x approaches c of f of x minus f of c over x minus c. So you can already recognize your c value is going to be 2, and our function is natural log. So really this limit here is f prime of 2, where f of x equals just this, natural log of x minus 1. So I need to find f prime first. So f prime of x, derivative of natural log is 1 over, so we have 1 over x minus 1. Chain rule would just be times 1, so we're good there. So then f prime of 2 would be 1 over 2 minus 1, so 1. All right, that's all. Thanks for watching.